Ever find yourself leaning into a curve? Maybe you're on your bike, picking up speed, or even just walking briskly around a corner.
It's almost instinctive.
Totally.
Yeah.
Just lean in. And that, believe it or not, is the basic idea behind today's deep dive. Tilting trains.
Ah, tilting
I'm going
trays.
to unpack why they lean, how they actually work, and why they aren't just everywhere.
It's a fascinating area. I mean, the whole concept of taking a train, something usually stuck on a fixed track, and engineering it to move with that kind of agility even at high speeds.
It's remarkable. And you might be thinking, why not just build straighter tracks?
Right.
But picture this. You've got these rail lines, some over 100 years old,
Yeah.
and now imagine trying to reroute miles of them for high-speed travel.
Logistically,
A nightmare. And don't even get me started on the cost.
it's the classic infrastructure dilemma. Spend a fortune on brand new lines, or find a smarter way to work with what you already have.
Exactly. And that's where tilting trains come in, right? That kind of elegant workaround.
You could say that. It's a way to potentially increase speeds on existing lines without needing a complete overhaul.
Like a compromise between physics and budgets.
Exactly.
But it's not just about squeezing more speed out of old tracks, is it?
You're right. Tilting trains have also been seen as a way to push the limits of high-speed rail itself.
That's exciting.
To achieve those really high speeds, you often need dedicated tracks that are almost perfectly straight.
Makes sense.
But tilting trains, they offer the potential to reach those speeds without needing those perfectly straight lines.
It opens up a whole world of possibilities.
Yeah, but
I've got to be honest, though. The engineering involved still kind of boggles my mind.
it's pretty amazing stuff.
We're talking about a train, something massive, leaning at speed.
It seems impossible.
It does. So to really get this, we need to go back to basics, back to physics class.
Back to the basics.
Specifically, centrifugal force.
Yes.
That force that feels like it wants to throw you off a merry-go-round or, send you flying when you take a curve too fast.
Exactly.
And trains, as it turns out, have to deal with that same force.
Absolutely. When a train goes around a curve at speed, centrifugal force pushes it outwards.
And if it's going too fast.
It becomes a problem, not just for passenger comfort,
Right.
but for safety too. And that's where tilting trains come in. They're designed to counteract that outward force.
By leaning into the curve.
Precisely. Just like you would on a bike.
So they're tilting to stay balanced, essentially.
You've got it. They create what's called artificial cant. Now, normal train tracks, they already have a slight inward tilt on curves.
Oh, really?
Yeah, it's called cant. And it helps a little with the centrifugal force. It's like leaning into a turn on your bike.
Okay, I'm picturing it.
But there's a limit to how much you can tilt the track itself. Go too fast, and you get what's called cant deficiency.
Cant deficiency, so not enough tilt.
Exactly. The train's going too fast for the curve, and it feels like you're about to tip over. Tilting trains, they solve this by adjusting their lean dynamically.
Okay, hold on. You're going to have to break this down for me. How does a train actually lean like that, especially when it's going full speed? It sounds like something out of a movie.
It's really quite ingenious. It's not magic, though it's pretty close. There are two main ways these trains achieve that leaning magic.
Two ways. Okay, tell me about them.
The first is called passive tilting. It uses a combination of mechanics and gravity.
So low tech.
You could say so. Think of it like a pendulum. The
Yeah.
train car wants to stay upright, so as the wheel sets tilt, the car naturally leans into the curve. It's a bit like a tilting toy.
Huh, I kind of get it.
The Spanish Talgo trains, they use this system.
Interesting. So what's the other method? You said there was another one, right?
Right. The second one is called active tilting. This one uses computers, sensors, and hydraulics to control the tilt.
Wow, so way more high tech.
Definitely more complex. It's constantly monitoring the train's speed, the curve's radius, and adjusting the tilt to match.
So it's like the train has a brain that's figuring out the perfect angle for each turn.
Exactly. The Italian pendolino, that's a good example of a train using active tilting.
Okay, that's impressive. And I'm guessing these tilting trains, they can achieve some pretty impressive speeds, right?
They can. The pendolino, for instance, can reach 250 kilometers an hour, even on tracks that would force a regular train to slow down considerably.
250. Now that's what I call fast. But tilting trains, they're not just for high-speed rail, are they?
You're right. They're pretty versatile. You get diesel-powered tilting trains that are great for suburban and regional routes. They might not hit those super high speeds, but they can comfortably cruise at 160 kilometers an hour.
Still pretty zippy.
Yeah.
So are we saying tilting trains are basically the future of train travel then?
Well, they have a lot of potential. One cool thing is that some tilting trains can even run on different track gauges.
Wait, different gauges. You mean like the width between the rails?
Exactly. It's a huge advantage for international lines where the track gauge might change at the border.
Huh. Never even thought about that. It's like they thought of
That's
everything,
amazing.
but with all this talk of speed and efficiency, I got to ask, how much time are we actually saving with these tilting trains?
Well, studies have shown they can cut travel times by anywhere from 12 to 33% compared to regular trains on the same route.
33%. That's a serious chunk of time.
It is significant. Of course, it depends on the route, how many curves there are, how sharp they are, things like that.
Right, right. I guess it's not a magic bullet.
Not quite, but I will say the technology is impressive.
It really is. But I imagine, with all this fancy tech, these trains must be expensive to maintain.
That's the trade-off. Tilting trains do come with some drawbacks, and cost is a big one.
Yeah, I can imagine. More complex technology usually means a higher price tag.
Exactly. Building a tilting train can be anywhere from 3 to 20% more expensive than a regular train.
Wow, okay, that's a pretty big difference. So it's not exactly a no-brainer then, is it?
It's a complex decision. You have to weigh the benefits against the costs.
And I'm guessing maintenance is another big factor.
Definitely. The track maintenance is similar to regular trains, but those tilting mechanisms, they require specialized parts and expertise.
Right, so more expensive to maintain too. It seems like there's always a trade-off. So are tilting trains the ultimate solution for faster rail travel? Or are there situations where it just doesn't make sense to use them?
You've hit the nail on the head. They're a fantastic tool, but they're not always the answer.
So when do they make sense and when do they not?
Well, sometimes, especially when you're talking about really high-speed rail, building brand new tracks or doing a major overhaul of the existing ones is just the more practical option.
So it's not a simple decision. But I'm curious, with all these costs involved, how do they even figure out if tilting trains are worth it?
It's a big question, and there's no easy answer.
Yeah, I bet.
There are so many factors to consider. You know, our research actually mentioned that French railways, they found that saving just 1 minute of travel time with tilting trains could cost millions of euros.
Millions for a single minute. Wow. It really highlights how complex this issue is.
It does. It's about so much more than just speed.
Right. You've got to factor in the cost, the maintenance, even the environmental impact.
Exactly. It's a balancing act.
It really is.
Yeah.
And it makes you wonder, if tilting trains are sort of a clever workaround for older systems, what's next? What other innovations are out there? What about things like battery-powered trains or hydrogen-powered trains?
Those are definitely areas of active research and development.
Exciting times. Maybe we'll do a deep dive on those in the future.
Yeah.
But for now, I think it's safe to say that tilting trains offer a pretty amazing example of how engineers are finding creative solutions to make rail travel faster and more efficient.
Absolutely. They really are a fascinating feat of engineering.
They are. And it's a good reminder that even something as seemingly simple as a train leaning into a curve can be incredibly complex, involving engineering, economics, and even, I'd say, a bit of philosophy about how we value our time and our resources.
That's a great point.
Well, that's what we love to do here on The Deep Dive. The Deep Dive, we take these everyday things like tilting trains, and we uncover all the hidden complexity.
We'll get into the nitty-gritty.
Exactly. We want to make you think twice about the world around you. So next time you see a train gliding smoothly around a bend, maybe even at high speed, remember those tilting marvels we talked about today? It's a pretty incredible feat, and who knows, it might even be a sign of even more innovative things to come.
I'd say so. The future of rail travel is looking bright.
I like it. Well, that's all the time we have for today's deep dive on tilting trains. Thanks for joining us, and remember, keep exploring, keep asking questions, and most importantly, keep that curiosity engine running.